student, so after completing the second problem, which was quite difficult, now let's move to the third problem. Now here guys, again the difficulty level is raised, and here we have to use the partial differentiation of second order concept with the concept of limits. So let's say how to solve such type of numerical. So here u is given as e to the power ax sine of x plus bt, and it is given that u equal to e to the power ax sine x plus bt is a solution of del u by del t is equal to mu del square u by del x square, with the condition that u tends to 0 as x tends to infinity. And guys, we have to find out the value of a and b. Now if u equal to e to the power ax sine x plus bt is a solution of this given differential equation, then guys it is similar to the concept which we have learned in 12th standard in differential equation chapter. So whenever equation is given or a function is given and it is said that that function is a solution of some differential equation, then that time what we do is, if we differentiate that function according to the equation and if we put that value in the function, then we get the both sides as equal. So it means if I find out the value of del u by del t from this u and del square u by del x square from that u, and if I put those values over here, then I should get both sides as equal, because this u is a solution of this differential equation. And guys, after substituting these values, there is an unknown called as mu, and due to that as well as using the given condition, we can get the value of a and b, because a and b are the unknowns which are present in the value of u. So guys, let's start. So first of all, I'll find out these two values. We'll put those two values in LHS and RHS, and after getting the equation, we will compare the two sides to get the value of a and b. So let's start. So here I'll first find del u by del t. So for that we will partial differentiate this u with respect to t. Now guys, in this term there is no t, which is constant. I'll keep it as it is, and this sine term will become cos of x plus bt into b. So this is the value of del u by del t. So here I have assumed x as constant because it's a partial differentiation. Now let's find out del u by del x first, and then we'll find del square u by del x square. So to find this value, again if you see this function u, then here there are two functions and they are multiplying each other, and in both the functions we have x. So it means we have to use the UV rule or the product rule of derivative. So by using that rule we will get e to the power ax as it is, and the derivative of this function is cos of x plus bt, plus this sine of x plus bt will remain as it is, and the derivative of e to the power ax is e to the power ax into e. Now guys, here I can take e to the power ax common, and in the bracket here we will get cos of x plus bt, plus here we will get a into sine of x plus bt. Now this is the value of del u by del x. Now let's find out del square u by del x square. So for that I have to again differentiate this function with respect to x, and in this function there are two parts which are multiplying each other, so I'm going to use the product rule of derivative. So here I'll say del square u by del x square equal to, so let's apply. So e to the power ax will remain as it is, and we will find out derivative of this second function. Then we'll keep second function as it is and we'll find out the derivative of first function. So what is derivative of this second function with respect to x? So derivative of cos is negative sine and derivative of sine is cos. So we will get Now plus the second function as it is, so I'll copy down this function, and derivative of this is e to the power ax into a. So we'll get now guys, let's simplify this right hand side. So for that I'll multiply these brackets with e to the power ax and here with e to the power ax into a. So we will get this as negative e to the power ax into sine of x plus bt. This will be plus a e to the power ax cos of x plus bt. Here if I multiply this term with this a into e to the power x, we will get plus a e to the power ax cos of x plus bt, and this will be plus a square e to the power ax, and guys this is the value of RHS. So now we'll put these two values in LHS as well as RHS, and then we'll try to find out the value of A and B. So left hand side is del u by del t. I'll put this value in the LHS. So here I'll say so guys, here I've substituted the value of del u by del t, that is this value in LHS. Now for RHS I'll put this value and we'll multiply by mu. So this is the value of RHS. Now guys, in this value you can observe these two terms. So these two terms are exactly similar. So I can say that this term is 2 times. If I add these two terms, we'll get 2 times a e to the power ax cos of x plus bt, and these two terms will remain as it is. So it means overall we will get 3 terms. One addition of this, that is second term, and this one as the third term. And for these 3 terms we will multiply by mu. So by multiplication with mu to these 3 terms, we will get here now if I multiply this second term, that is addition of these two, by mu, we will get and if I multiply this third term with mu, then we will get now guys, after multiplying with mu, now we got both the sides. Now from both the sides I can cancel the term e to the power ax which is there. So from both the sides I'll cancel this term, and now we will take cos terms together and sine terms together. So here by doing that, what we'll get is I'll shift this b cos x plus bt on this side, so it will come together with this term and we will get 2 mu a minus b into cos of x plus bt. Similarly, these two terms together, that is sine terms, we will get plus mu a square minus mu into sine of x plus bt. And on the other side, there is nothing, so I'll make it as 0. Now guys, we got one equation. So the question is how to get the answer. Now, my question to all of you, we are adding two terms and the addition of these two terms is equal to 0. So there are two chances. One is either both terms will be 0 or the value of both terms will be opposite to each other. It means if it is positive 1, then this will be negative 1. So these are the two cases possible, right? Now Since we don't know the positive and negative value of two sides, we will assume that these both functions are 0. This is one way. Or what you can do is you can compare the coefficient of cos and sine on both sides. So it's a kind of a comparison. So here the coefficient of cos is 2 mu a minus b. On the right hand side, we can say that the coefficient of cos is 0. So we can say that 2 mu a minus b is equal to 0. And if I compare coefficient of sine on both the sides, here we have mu a square minus mu is equal to 0. So guys, here we got two equations. So what we did is we have assumed that these two terms are 0. So how it is 0? So we have made the coefficient as 0. So if this coefficient is 0, this terms become 0. If this coefficient is 0, this term is 0. Now let's solve these two given terms. So here I will get the value of b as 2 mu a, and here we will get mu common and a square minus 1 equal to 0. Now guys, mu was taken as any arbitrary constant because it is given in the question. So what I can do is I can shift this mu to the other side, that will become 0 by mu, and we will get a square minus 1 as 0, that is a square equal to 1. So therefore the value of a is positive or negative 1. Now the question is, what is the correct value of a? So should I take positive 1 or negative 1? And for that we have to observe the given result, because guys, if I take the positive 1, then the value of b becomes 2 mu, and if I take the negative 1, the value of b becomes negative 2 mu. But to decide the value of a, we will go in the question. So in the question, one condition was given, and the condition is u tends to 0 as x tends to infinity. Now guys, let me explain you this. So as x tends to infinity, here we will get e raised to infinity. Now guys, there are three formulae which you have to understand. The first formula is e raised to infinity is always infinity, and e raised to negative infinity is 0. And the third one is e raised to 0 is 1, which you all know. So if you see these two formulae, then now come here. Here it is given that x tends to infinity, then u tends to 0. So if we want u as 0, then this power of e must be negative infinity, because if it is negative infinity, then only we will get answer as 0. So guys, here if I want to get this power as negative infinity, the value of x tends to 0. So it means this a must be minus 1. So if a is minus 1, we will get negative infinity and we will get answer as 0. So we will assume a as minus 1. So if a is minus 1, then we will say b is negative 2 mu. And guys, these are the values of a and b. So here we got the value of a and b, and I am sure that you understood how I got the value of a and b. So keep watching the videos and keep following Ekeeda channel. Thank you very much.